Hello everyone, and welcome to the graveyard. Have a seat, grab a drink, enjoy the show. How are you guys? Let's go to somewhere. There's actually some music. Wait, what the hell? No, stop. Fucking hell. I was not expecting that. I forgot about that. Let me turn on studio mode and remove that shit. There. That should be it now. It shouldn't be appearing now. Thank God. Anyway. Little bit of scuff at the first start, but it's okay. It's fine. And hello everyone, welcome to the Graveyard Club. Now I'm finally streaming on all three major platforms. Twitch, Kick, and YouTube. So yeah, you can find me on all of those. Does my social comment still work? Should. Nope. I don't see it, damn it. God damn it, Graveyard Club. You had one job. Let me check what the issue is. So commands. We have socials. Indeed, a command. Sources can be YouTube message, Kick message, Twitch message. And it goes to good question. Just so I can't remember where it goes at all. Yeah. Don't think if I have socials even. Do I? Maybe. Not events. Not error. Not kickbot. Timers. Maybe so under socials. It should be working like socials. But there it is. And I should be changing that too. Not just Twitch, depending on the source, huh? Wait, let me try this one out. For some reason, Kick doesn't think I'm on Kick. I know. What the hell? Give me a moment. Sorry about that. It just seems like I did not log in. Why the hell not? Okay, then stop the authorization, please. Let me try it again. Thank you. Allow access. Now it should be working. Finally. Sorry about the scarf. It do be happening sometimes. Oh, now it appeared there as well. Okay. God damn it. That's what the issue was. Okay, so that works there. You know what? Let's go over the screen. You can see me here as well. And you know what? Let's add the subtitles as well, because why the hell not? Maybe it's easier to or worse to understand me. We'll figure it out later on, but that's fine there. Yeah. No, thank you. Wait, how do I? Did delete it as well? Yeah, I did. Ah. And now I need to get rid of that thing over there. Give me a moment. Should be fine now. That's deleted as well. Isn't there some auto moderation here? I guess not yet. We'll see, we'll see, we'll see. Anyway, that happened, and we're gonna ignore that. So, what we came for here today is... Good question, I don't know, something. Why are you still giving me emails? I did exit you, right? Yep. So then what the hell? Didn't I exit you, Vivaldi? Seems like I did not fully. And task. Thank you. So yeah. Wait, what? Oh, I forgot I had this, the zoom in. Ah, oh, technology coming back. Oh well. Anyway, my today's goal is, well, learning a bit of CCNA. Basically, Cisco Certificate Network Associate is an entry-level information technology certificate offered by Cisco Systems. Basically, it's a basic level of understanding of IT networks. I kind of need it because the last month or two, I started learning about networks, and I used a friends of mine's place as a testing ground. And I bought a router because their old one just was dying a lot, and he could not use it. So I bought a new one for him, but with the pretense that I want to try and hack it. And what I bought was a Bailey MR. Let me go for the Hungarian one. It's this one. Why is it so fucking small? TL MR or MR 6400 or 6400. Which we needed because of the LTS stuff. But the issue was I installed OpenVRT on it, which is an open source router software. And it's amazing, but it barely worked with our router. Even though it kind of supports it, MR. But the issue was the support goes up to version 5. In Europe, there's version 7. It just barely worked. So many issues, not just because it needed daily restarts, but also because the LTE barely worked. LTE. LTE. Anyway, barely worked. It also had some issues with some computers that tried to connect and just flooded logs with it. And after a while, it caused that the memory fill in and just scrap. The router just scrapped itself. I might need to debrick it. Anyway, that's for later on. Now I am trying to learn about the basics. So when I do it next time, I know what I am doing and not just, oh, and never, let's not talk about the firewall stuff because I tried to set it up, but it did not work. I don't know how to check what connection is what, how they're trying to talk. I know the basic of port forwarding, but I need some advanced stuff because there's some devices that are the same type needs all of the port forwarded, but can I port forward to two devices? I don't know. And it's bothering me. That's why I decided let's learn the basics. If at minimum we can do something. And for that, I found this network check guy who has a free CCNA course, the one I exactly need. This is exam number 231. The exam test can be knowledge and skill required to install, operate, and troubleshoot small to medium-sized enterprise range network devices. I need exactly this. The exam covers a broad range of fundamentals, including network fundamentals, network access, IP connectivity, IP services, security fundamentals, automation, and programmability. This is exactly what I need. The same certificate expires after 3 years. They don't require certification to holders to register for PASA or higher level Cisco certification. Okay. So, with that said, let's dive into it. and join me as I learn about CCNA. Also,
This is day 0 of my free CCNA course, and a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams.
sure, all I need to know how to do it.
Woo! How did I do that? Well, it's simple, right? I clicked shoot and the computer shot, and that's what happened. But hold on a second though. I'm playing online, and the guy I shot isn't just in the game, he's actually playing a game somewhere far away from me. How did my bullet get all the way to him? Actually, come here with me real quick. Come here. So, that bullet has to...
By the way, I did watch some other network Chuck's videos because he has amazing home lab. And basically what I'm doing is becoming doing a home lab as well.
Flying over this Ethernet cable all the way down here. Come on, let's go down here. It goes into my wall jack here. Come on, let's go. It goes into my IDF, to my network stuff here in my rack. Comes through my walls, to my switch,
Jesus.
to my router and firewall.
Jesus, that's a switch, that's a router and firewall.
To my modem. And where does that go? Come on, come on. Goes to my AT&T fiber box, and then to the internet. Okay, the internet. You probably saw that coming, right? Like, duh, Chuck, we play online on the internet and we play Call of Duty with other people. But what happens after that?
But he has some crazy setups.
I've already shown you how it goes through your entire network. This is what you have right now. If you're playing Call of Duty online, this is your local area network. But what happens when we go outside your home to the WAN, or the wide area network? Let's see. And the internet will just be more routers, just someone else's routers. Hip-hopping across great distances. And that's all the internet really is. Just a bunch of routers connected. But of course, it's not just routers. You'll have switches here, firewalls, just all kinds of stuff in all the networks. But the cool thing is that in the blink of an eye, as fast as you can fire
the modem or router as well,
things are going across all these routers.
Or is our consumer routers are mixed between switch router and modem?
Because your bullet has made it to Call of Duty, but now Call of Duty has to send your bullet to the guy who's about to get shot. So, again, we go back up to the internet. Bam, back to the router. And this could be another path, hopping from router to router to router until it finally arrives at my brother's house. Because he is the one I shot, and it will hit his modem, his router, his switch, travel through his Ethernet cable to his PS4, and he gets shot. Crap! Now, why did I show you this? Why would I show you how a bullet can travel across the internet? Well, I did it as a test. What I'm hoping is that if you saw this, you would go, wow, I want to know more about how that works. I want to do something like that. If that was you,
I need to.
This course is for you. The CCNA is for you. Because what I just showed you is what you'll be learning in the CCNA. Networking, how networks work. Now, if you look at this, the networking we have now is pretty complex. But the goal is the same as it was 20, 30, 40 years ago. I want my computer...
Yo mama's so short that when she sat on the curb, her feet didn't touch the ground.
God damn it, big girl.
And that's how networks came about. It was one computer.
Mama is way short, yes. Hey, Sada, welcome.
Right now without a lot of effort. So, you know what?
Let's learn some CCNA together.
Networking was born. We can still do this, by the way. You can use an Ethernet crossover cable just to connect two computers together. But Mark, he wanted to talk too. Mark over here was left out in the cold. Oh, hi, Mark. So in comes switches. And a switch will allow us to connect more than...
How are you? Welcome.
How are you? Printer. Oh, by the way, just so you know, I'm glossing over this. There's a lot more involved.
Then learn with me because I'm learning here as well. I'm trying to learn it. Oh, how was your first day? How was your first day?
broadcast domains, MAC addresses, VLANs, all kinds of stuff with switching. So just know this is just the tip of the iceberg. But if you like this, you'll like the other stuff too. Now, this is a network, and a switch facilitates that. All these computers are connected together, they're inter-networked together, and they are having a blast, talking to each other, playing games, whatever. Now, a switch can only handle so much before there are too many computers talking, too many things talking
It
at
was
once.
this.
And he's like,
Why too much
I
sitting
can't
though?
do this. So what do? Well, we get another switch. Easy enough, right? So easy. And we connect more computers, and they have a blast. They're having a good time. Yes. And yes, the more computers
Workplace
that draw,
safety and
the
fire.
worse they
Yeah,
get.
that's kind of needed.
You probably can't
Honestly,
tell
I
the
still
laser
have some courses I
probably
need to
label
do,
my switches, right? Let's just
and
call
I
them
keep
switches,
forgetting.
so you know what's going on. Now, what we have here is essentially two networks. Let's just call this network 1 and network 2. We got a problem though. What if Bob over here wants to play a game with Mark, but they're not connected together? How do we solve that problem? Well, that's where routers come in. Routers. I'm not going to draw one. I'm just going to bring one in. A router will help these two networks talk. That's what routers do. They help networks talk to each other. So we connect our switch up to our router. Bam, bam. And a high-level view, extremely high-level view of how this might work is Bob's like, hey, I want to talk to Mark. So he says, Mark, are you here? And everyone's like, no, Mark's not here. So Bob's like, well, maybe he's over here. So he goes to the router and says, hey, router, is Mark anywhere? Do you know about Mark?
Yeah.
And the router's like, yeah, I think I might know where he is.
And he sends over to the other
Hey,
switch.
Mark is over here. And now Mark and Bob can talk to each other. So where does the internet come in? Well, this might be just one section of the internet. So we'll put them down here.
Alright,
Another
I have
router
I have
with
a
another
good
situation.
appetite.
And by situation, I mean another switch with a bunch of computers who just want to hang out with people and talk and play games. And we connect these two routers together.
Right,
And the
wait,
internet
there is some
just
music
this
requests here,
times
so if you
1,000.
guys
Now
want.
again, I've got to say this. If you were to pop the hood on the internet and look inside, it's pretty complex. Like, there's a lot of stuff going on. So keep in mind what I'm saying here is very high level, but that should be exciting to you. Like, wow, I can't wait to learn more about how all this works. And we'll definitely cover that. Okay, so we looked at our switch and we looked at our router. What about this guy? What's a firewall doing? Well, simply, he's protecting you. He's protecting your network. Now, as you may know, there are some bad people out there, some bad dudes that want to attack your network, that want to steal your information. These hackers are constantly trying to find ways to steal your stuff. And while they'll try to get into your network, a good firewall will keep them out. Now, again, with networking, routers and switches, we want to connect people, connect computers, connect devices, smartphones and smart lights and all kinds of stuff. And that's normally good. But then there's bad things, and that's where a firewall comes in. A firewall's job is to block anything that shouldn't come through or go out, and only allow the good stuff. Now, I'm hoping at this point, some of you are probably going, well, Chuck, I don't connect anything to a switch in my house. There's no cables anywhere. What are you talking about?
Because most people have only a router that's a modem and a switch in the same time. So that was recommended to certain users of it. Really? Which one? What users?
Well, you're right. For the most part, most of the things we use in our networks,
As long as it's not picture or video, I'm fine with
you'll
it.
learn about wireless. But where does it come in? Well,
Chatbots.
here's how you would do it. Let's take Cameron's network, for example.
You want an AI girlfriend?
Has what's called a wireless access point, often referred to as a WAP. And this device is designed to broadcast the network over airwaves. Airwaves that your phone can connect to.
Yeah,
Now, again, many of
AI
you
girlfriend.
networks probably have one device that has a access point, modem, firewall, router, and switch in one device, which is pretty amazing. Which might cause you to wonder, well, why does Chuck and his brother have separate devices for all these functions? Well, first of all, we're
Go
geeks.
get the girl already, Sada.
Second,
Stop
we do that because
dilly-dallying.
we are network engineers, and this is what you'll see when you walk into a company, because a company, they won't have one device that does all this. Companies will typically have a lot more people, a lot more things on their networks. So they'll need bigger switches, bigger firewalls, bigger routers, more access points. So they just need more, and they need more features. If you're curious about what I have,
I'm trying got her heard balloon last Friday.
Now again, this will be a free CCNA course. CCNA being the Cisco Certified Network Associate. It is
Got a
one of
smooch in it.
the main IT certification you'll want to get.
I say be more assertive.
Becoming a network engineer. What's a network engineer? Well, what I just showed you, the whole Call of Duty thing, the bullet floating through space and getting to my brother across the internet. A network engineer makes all that stuff work. They design things like that. They make sure those things stay up. That's their job. And the CCNA will begin to teach you about those technologies. Understand them, build them.
Yeah.
How they work. And we look
I
at
want to do
devices
that.
right now. Switches, routers, firewalls, wireless access points. We'll later look at network controllers and where servers come into play. I mean, we saw the Call of Duty server, right? But we'll look a bit deeper into, well, really what is a server and how does that affect our networks? So free, what are you getting? I got to make sure you get your money's worth. So I will be doing one video a week. and this will be a complete course covering every topic in the CCNA. Now,
Yet
large reason
there
I can
is
do
like
this
24
for free is
videos.
because of my sponsor, Boson Software. If you've watched me before, you know I talk about them a
Just
lot.
go and ask her
They're by far
out.
the best labbing and
Just go
practice
and ask
exam
her out.
software
Go
out
on
there for
dates.
CCNA and CCNP. No joke. And they have other stuff too, but CCNA, CCNP is what I've used them for, and they're fantastic. That being said, I will be using them as my lab demonstration, and I will be throwing up practice
Sada, she wants you to step up and ask her out.
Right now, 25% off. It's their summer sale. So if you want to get Boson, now's the time. I've got links below. Now, if you have questions, hey, this is my first video. Just getting started. So I'll probably end up answering a lot of your questions. And, you know, I've been talking about the CCNA for a very long time
do
on my
it.
YouTube channel. So I probably have answered your question already if you look back through my videos. Otherwise, I'm here to help. Leave a comment below if you have.
You know what? You know what? Ah. What are signs that girls...
Connect these two routers together. And the
Oh,
internet
fucking hell. There.
How do you know when someone likes you? It's a challenging language to understand, but if you pay close attention, you can unravel someone's true feelings. Here are 10 signs that your crush likes you. 1. They fixate on you. You unconsciously fixate on people, places, and objects that you want the most. 2. They lean toward you. Around someone you like, your body springs forward. 3. They're vulnerable with you. But when you're around someone you trust, those walls come crumbling down. 4. They smile at you. A genuine smile can demonstrate trust, attraction, and vulnerability. 5. They open their posture. Each of these nonverbal signals creates a physical and emotional bond with someone. 6. They look into your eyes. It's a great way to express your interest. 7.
See?
They make physical contact. 8. They make time for you. Each time your crush makes time for you, they're leaping over one of these hurdles. 9. They copy your behavior. When you like someone, you mimic their posture, actions, and facial expressions. And 10. They invest in you. When you lend something to your crush, you're making a small investment. Share
See?
this video with someone who might benefit from it.
Does any
How
of
do you
this
know when someone likes you? It's a
work with you? We can watch some more if it helps. Here. Seriously, so just go and ask her out. I don't think you will. You will.
questions about this.
I
It could be
think
about,
you
hey, how long
will
did it take to study for
get
CCNA?
her.
Will it help
I
you
honestly
out?
do.
Is this even worth it? I mean, I've explored that. I have this.
If you get smooches, she invites you.
It served me pretty well. Well, guys, that's all I got. I am stoked, like legit excited to start this course.
Try
I can
it.
honestly say the CCNA changed my life. I know it's changed. This
Because the other situation is that you're in her friend zone, and that's not a good
is
place.
day one of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. Day one, we're not wasting any time. We're getting right into what is this? It's a switch. How does it work? Why is it amazing? Because it is amazing. And we'll even get a chance to lab. What does labbing mean? Well, you'll find out. We're going to use Cisco Packet Tracer to analyze frames and packets going across a network. And you're going to get a chance to enter your first Cisco CLI command. Let's get started.
I find it hard to believe the French is going to the friend zone. If she French kissed you, then ask her out. It's a clear sign. Stop dilly-dallying around.
In my last video, we talked about what a network is, and we followed a Call of Duty bullet when I shot it from my computer, how it goes through my home network, to my
we
brother's
just saw
network,
this.
and shoots his character. And we went high level, like router, switch, firewall, access point, what are those things? But we didn't go too deep. But now, Are you ready? We're gonna go just a little bit deeper. This is like one of those red pill, blue pill situations from the Matrix.
After this,
Yeah.
there is no turning back. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes.
You take this pill, there's no going back.
Let's go with
You're
red
going
pill.
deep into the networking rabbit hole. You're gonna fall in love and never look back. Okay, I warned you. You're still watching this, that means you wanna keep
Yes.
going. Let's do this. Okay, let's talk about switches first. What are they and what are they doing? And here's one right now. This is a switch. It's beautiful, isn't it? Look at this. Oh, love it. Now, if you watched our last video, you have a high-level view of what a switch is for. What's it doing? Well, it's helping our computers to connect to each other and talk and hang out and chat, send data. We
Yes.
connect using these Ethernet cables and we plug them into our ports. Oh, I love that sound. Here, listen to this, up close. ASMR version.
Yeah,
my
they have
favorite
nice
sounds.
click sounds.
So we connect one computer, connect another computer, and assuming we have computers on the other ends of these, they're talking, they're having fun, they're playing games. But what's really going on inside of here? Let's pop the hood, let's take a look. Oh, and by the way, switches can come in many different sizes. Like this is
My BFF came to the pub with me, met my potential girlfriend, and fucking went, oh, you went do it. Then, Sodo, why are you dilly-dallying?
an 8-port, and this big boy is a 48-port. He's beautiful. Why do you need 48 ports? Well, so you can connect 48 different devices to each other. That's why. Now let's first look at this guy, the Ethernet cable. All it is a bunch of metal wires. Like, check it out. Ah! Your computer communicates with the other computers via electrical signals, and these electrical signals go down these wires.
I understand you're made of an accelerate, but if you don't step up, you will not get the girl. You need to step up once to score, and you have it. Do it, Sada. Do it.
Wires through the cable to the switch, and then it goes to the other computer. It's amazing. It's just electrical signals going in and out of these ports. Isn't that cool? Now, switches are
It is
amazing,
cool.
but for you to really appreciate how amazing they are, you need to look at their predecessor, the one that came before them, the hub. He's disgusting. He's dumb. He doesn't have any
Then ask her out on a date where it's just the two of you.
smarts. The switch is smart. The hub is not. But before we had switches, hubs are all we had. And here's what they did and why they're dumb. Now, I want you to actually see how dumb this is and experience it for yourself. So right now, what I want you to do is go download Cisco Packet Tracer. I've got a link below. Sign up for a free account through NetAcad.
Okay, let's do it. Insta Packet Tracer. And how do I getting started with? Maybe this one. Download. Okay, get started with set. I need to fucking. Oh, continue with Google. Perfect. I am in Hungary. In the big state, city, and I am old as hell. And NaGeL Bailey. Perfect. I agree to sell my soul. Can I get the packet now?
Whether you're pursuing a relationship, apply real network.
Yeah. First time course. Yeah. Get started with Cisco Packet Tracer course designed for new users. Of course. I want to download it. I am on Windows, so give me the Windows Packet Tracer. And put it into downloads. I have no idea what cybersecurity lab VM is. And there is a Kali Linux as well, but I only need a Cisco packet tracer. It's slowly getting down.
And you'll be able to download it. What is this? It's a tool that lets you build and play with networks and so much more. It's amazing. So go download and install that. It's on Windows, Mac, Linux. And once you install Packet Tracer, I've got another link below for a Packet Tracer file, which is a lab I built that we can play with right now. So go ahead and download.
All right. I'm downloading, or IG. Hello. Okay. I accept to sell my soul. Install. Sure, why not? Install.
Download that and launch it. Do not get overwhelmed with all.
And I need to download this as well. Tracer Lab. Why do I have feeling I have put the exe into the wrong place? Because I think I have. Let me check a moment. Cisco Packet Tracer. Okay, I put it in the wrong right place. Okay. Finish. Would I run multi? Sure. I have zero idea what that is. Multi-user. And let's log in. Thank you. And I should be opening downloads, Tracer Lab, this one. Network chalk, yay! How do I move? Okay.
Buttons and options here. I'll walk you through every step right now. If you zoom in right here, I've got two networks. I got this one here, which is a switch, and my laptops. If I scroll over, I've got another network, and it's not nearly as smart because I'm rocking a hub. Now, a hub and a switch physically kind of look the same. They look like this. They have ports where you can plug Ethernet cables into, but they're so different. Actually, we can look at a hub right now. Let me click on the physical button up here. I can click on my home city, my corporate office.
Physical. Yeah.
And then jump into my wiring closet, and there it is. So you can see switch, it's got ports, hubs, got ports, okay? But why are they different? How would you like this? If when you sent a text to your friend, it didn't just go to your one friend, it went to all your friends. And then when your friend responded back to you, it not only went to you, but it went to all your friends as well. That's stupid, right? Like that, I would never use that texting platform. That's what a hub is. Check this out. And I want you to do this with me. So click on simulation down here at the bottom right. This is what makes Packet Tracer so...
You know what? Oh, Jesus. Let's try to put it out like this. And I can have still this one here. Can I go back? Yes, I can. It's kind of hard to move it around. Let's continue.
We can analyze the network traffic slowly as it goes through the electrical wires. It's powerful. Anyway, so don't touch that. Leave it there. I want you to click on Harry Potter up here. Laptop Harry. Then click on desktop and then click on command prompt. This is very similar to a Windows command prompt. It kind of is a Windows command prompt. And what we're going to do is we're going to have Mr. Harry here talk to Ron over here through the hub. We're going to send a message that we use in networking all the time called a ping message. What is that for? We use it to see if other computers or servers are up and can be reached. Kind of like this.
Yeah, it can be reaching.
Ping!
Reply!
Ping!
Reply!
You may have noticed I've got a couple things right here. Layer 2 address and layer 3 address. Now what's an address? Well, if I wanted to send you a message, I might send it to your email address. If I wanted to send you a letter, I might send that to your mailing address. It's something unique to you that allows me to send something to you. Data, whatever. And in the networking world, it's the same thing. Now, what does layer 2 and layer 3 mean? We'll cover that here in a bit. But just know that when I'm going to send a ping message to Ron, I'm going to be looking at his layer 3 address. That might look familiar to you. What is that? Well, that's an IP address.
An IP address.
You're probably familiar with that, right? Harry knows that when he wants to talk to Ron, that's his address. That's his phone number. That's his mailing address. That's how he gets information to Ron, his IP address. So here we go. We're about to ping Ron. Now, please make sure you have the simulation button checked. Not real time. You want simulation. Here we go. Get your command prompt open. We're going to ping Ron. So I'll type in ping and then Ron's IP address, 10.1.2.3. Now, watch what happens when I hit enter.
Yes.
Boom. A little envelope popped up. A little message we're going to send to Ron. And then notice over here we have a little event timeline where that message just popped up.
Yeah, here it
Play
is.
here. As we get more advanced and go deeper and deeper into what's happening, which will actually happen in the next video, we can click on these and look at some hairy details like, what's happening? Don't worry about that yet. We'll get into it. But it's amazing. So Harry wrote his letter. He's ready to send it. And if we click on this little advanced button right here, it'll take a step forward in time. Let's go ahead and do that. Click advanced. Boom. One more time. Boom. There it goes. It's going across the network. Electrical signals firing. So now the hub has the message. In an ideal world, in a perfect world, the hub's like, oh, okay, well, this message is from Ron. I'm going to send it to Ron. But the hub's an idiot. He's dumb. Watch what happens. Watch what happens.
Oh, there's lots of information. This is the outbounding details. I'm sending. And this is where it... Wait a minute. Then what's this one? The RP takes out its packet from buffer and sends it. Wait, what? Then what's this? The ping process starts the next ping request. The ping process creates an IP echo. Oh! The source IP address is not specified. Device sets it to the port IP address. It just sets up the data. Then works on it and then sends it. Fast Ethernet receives the frame, inbound, outbound. Next one is everything is sent out. The hub sends to everyone, I guess. IP destination address is 001. That is wrong. 001C. Oh no, that's back to Otter. Then this is 0143. That's wrong. It's an inbound detail. Back from Ron. But yeah, it sends to everyone.
Click next, and why did you do that, Mr. Hub? You sent the message to everyone. Harry's just trying to talk to his buddy Ron, and now Hermione knows and Malfoy knows. That's bad, right? Now watch what happens next. Remember, in a ping situation, Harry's going to send a ping, hey, you there, Ron? And Ron's going to go, yes, I'm here. But watch this.
Yes.
Click next. Ron does reply, perfect. But then watch what the hub does, the dummy hub. He sends Ron's reply out to everyone. Why, hub? Why? Well, again, the hub has no smarts. He's got no brain. His job is just to repeat that electrical signal. Whenever the computer sends down this wire, the hub's going to go tss and send out to everyone. This is how we did things for a long time. Now notice that over here, Harry Potter's got a green check mark going, yes, 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 that message is for me, yes, yes, yes. But then down here, Malfoy and Hermione have this X, which means that most of the time, in a hub environment, if a computer got a message that wasn't meant for them, it would just ignore it.
I'm just
But,
replaying
you
it
know,
again.
That's if you're a good person. If you're a hacker, like I'm learning hacking right now, if you get a message like that, if you're able to see everyone's traffic, you're like, yes, yes, give me more. I'm going to hack all you guys. Not a very safe and secure environment. You don't want to text your buddy something secret and all of a sudden all your friends know the secret. But now, let's look at the switch. He fixes everything. Go ahead and click on Reset Simulation. You can close out Harry Potter there. And let's scroll on over to the better environment, the switch environment. Now here, the switch has the same goal as the hub, just to connect these computers together so they can talk. So they're doing the same job. Just one's really, really good at it. So over here, let's walk through the same situation. Johnny right here is going to ping Mark. Oh, hi, Mark. And we'll see what happens, and I'll explain how it happens here in a moment. So go ahead and click on Johnny, click on the desktop tab, and then jump into your command prompt. We're going to type in ping, and then Mark's IP address right here is 10.1.1.2. We're going to hit enter, and bam, Johnny's got a message ready for Mark. Let's click on next and see what happens. Next. Next. Okay, there it goes. The switch has it. What's it going to do? Boom. So much better. Only Mark
And immediately sends it to someone.
Goes to Johnny. That's how it's supposed to work. Thank you, Mr. Switch. And if you look back at our command prompt, you can see that we sent a ping message and then we got a reply from Mark, from the IP address. Everything's good. Mark's alive. He's like, hey, yeah, Johnny, I'm here. And if we click on real time, it'll just complete it like it normally should. Bam, 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 really fast. Because these electrical signals are going really, really fast down these wires. But that's what's cool about this packet tracer. We can slow down time, bullet time, and watch it happen. Okay, we're about to go deeper. We're about to learn more about how this guy does things. Are you ready?
Yeah,
let's take a deeper look. The switch can do all this magic because it has a brain.
Hej Tanchona, welcome to the Graveyard Club. Have a seat, grab a drink, enjoy the show. I'm learning some IT networking, so come join me. Just learn what's the difference between a hub and a switch.
Where they are. So when you send a message, he'll go, oh, well, I know exactly where Johnny is. He's over here. Port FA02. He stores that information in something called the CAM table, which stands for Content Addressable Memory. Don't worry about that too much right now. We'll cover a lot of that later. Now, the switch doesn't know Johnny as Johnny. The switch knows Johnny as 00D097528936. That's how the switch knows Johnny, his layer 2 address. That's how the switch knows Mark. He doesn't know Mark's name, but he doesn't know 00E0B0590897.
What's a MAC address?
What are these things? That's called a MAC address.
Yes.
Referred to as a layer 2
it was a MAC address.
Every single device that you connect to the internet has a MAC address. Every one of them. Like, go ahead and look. Get your laptop out. Look for it. Like on this phone here.
Okay, question. If the MAC address is level 2 address, then what's a level 1 address?
I would connect to the switch. Look, right here. There's my phone's MAC address right there. It's often referred to as the here.
Ah, that's one.
There's my phone's MAC address right there. It's often referred to as the burned-in address because this address should never change. That's how your device is identified. It's a unique identifier. So when I connect my phone to the switch and my phone tries to talk to somebody, boom, the switch learns, hey, that phone, which that phone's name is 9C57803844A, he lives on port 1. So if anybody wants to talk to him, it's going to be port 1. Now we'll cover more about layers here in a moment. I'm kind of building up to that.
Yeah.
Like this right here, doing this, and that wonderful, beautiful sound. Yes.
Connection.
This is layer 1. Anything physical. The electrical wires, the metal wire that send electrical signals down into the switch. That's layer 1. So layer 1.
Wait.
Electrical signal.
So is wireless or layer 1 as well?
Firing at light speed down an Ethernet cable. Physical. And then we get to our switch, and now we're thinking about layer 2. And that's where our layer 2 address comes in. That's where the MAC address comes in. Layer 2 is often referred to as the data link layer, but we won't cover too much on that right now. I have to stop. I don't want to give you too much right now. Now you may be wondering, why isn't the switch just using the layer 3 address like what we used when we pinged 10.1.1.2? Why doesn't the switch know Mark by that number? Well, the simple answer is that the switch can't even see that number. It has no idea what it is. You see, the switch is a layer 2 device and doesn't know anything about layer 3 or IP addresses.
With then layer 3 is the application layer or not?
Or anything. That's why we're dealing with MAC addresses right now. Now watch this. Let's get back to our packet tracer. We're going to do a couple things here real quick. Let's click on simulation mode once more.
Let's try it, okay? Packet tracer simulation mode.
more, and let's open up Mark. We'll go to his desktop, go to his command prompt, and we're going to ping Lisa down here. So we'll do ping 10.1.1.5 and hit enter. The message was...
Wait. We're going for Lisa. That is ping. Just so you guys see it as well. Ping 10.1.1.5.
built. Now go ahead and click the forward message real quick. And I want you to click on this message right here we have. Click on it. Now, as you can see, we have 7 layers we're going to be talking about here very soon, but don't think about anything above layer 3 right now. Don't think about that. But notice this message we're sending to the switch. Notice it's not there. Layer 3 is missing. It's just layer 2. Because that's all the switch understands. And also notice the to and from. So right here we have the from, which is the MAC address of Mark over here. And then the to is to Lisa's MAC address down here. And if we go ahead and step forward in time, boom, the switch receives it. If we click on that message again, we see that the switch receives it, and he knows exactly where to send it because he remembers where Lisa is. And then if we click on that button, bam, it goes to Lisa. Now, I'm not sure if I want to show you this yet.
And it goes to...
So click on that immediately. Right there. The message that just arrived to Lisa. You can see here that instead of just having layer 1 and layer 2, we now have layer 3 involved. Because that's the layer that Mark and Lisa are talking on, layer 3. You see, we pinged from Mark's IP address 10.1.1.2 to Lisa's IP address of 10.1.1.5. And then Lisa's sending out a message, see, out, to Mark at 10.1.1.2 from herself, 10.1.1.5. And then if we step forward in time once more, boom, we see this message go to the switch. But then if we open that message, oh, layer 3 is gone again. It's just layer 2, because that's all the switch cares about is layer 2. And that's how he knows where things are. That's where devices are, based on their MAC address. I'll go ahead and click on real time, let that finish out. And we're going to jump into the switch's command line interface. And this might be your first Cisco command. Kind of exciting. So let's open it up. What we're going to do is we're going to look inside the switch's brain. So go and click on him and jump to the CLI tab. This is a whole new world for you. Yes.
Line
Now hit enter, then type in enable and hit enter. Now you should have a hashtag sign right there next to your switch. Here's the command I want you to enter. Show MAC-address-table. We're looking inside the switch's brain and looking at his CAM table, where he keeps the MAC addresses and how they are assigned to the ports. Because Mark and Lisa just talked, the switch knows that Mark, which is referred to as blah 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 MAC address, lives at FA01, and then Lisa lives at FA03. And then if we go to Denny over here, and we go to desktop and command prompt, and we try to ping Johnny, 10.1.1.3, it's going to go through. It's being successful. Awesome.
I'm a bit slower than what he's doing, but I'm trying my best here. 10.1.1.3. And yeah, it's doing its job.
If we jump back into the switch and hit the up arrow to enter the same command, hit enter, well, now the switch knows where everyone is. He knows where Johnny is, where Denny is, where Mark and Lisa. He learned it, stored it in his brain, and now whenever someone sends a message, he goes, I know exactly where they are. Boom, right there. The hub just doesn't do that. And that's the job of the switch. He learns where everyone is by learning their MAC address, their burned-in address, and stores that in his brain, in his CAM table, and marks where they are. So whenever he receives a message, he can forward those messages to the appropriate people, and not to anyone else that shouldn't hear about it. Now, when we're talking about layer 2, this message is referred to as a frame. All the messages going through this switch right here are frames. Boom, boom, boom. Frames just going around like crazy because it's layer 2. When you think layer 2, think switch, think frames. Switch, frames, layer 2. Switch, frames, layer 2. Is it working? Is it going in there? But then when the
switch layer 2 switch frames.
We're talking about IP addresses in layer 3.
Yes.
Do you know what it becomes? This message is now a packet. Now, just so you know, when you're talking to network engineers and other folks, they might refer to layer 2 messages, the frames, they might call those packets as well. We just get in the habit of it. If it's going across the network and it's going to people and it's a message,
it's a packet.
We often just refer to it as a packet. It just happens. But technically, it's frames. Layer 2 frames, switch.
Actually.
Layer 2 frames, switch. Okay, now we're going to talk a little bit about wireless. Here's a wireless access point, little baby Cisco one. Here's a bigger Cisco one. The reason I want to talk about them now along with switches is because they're basically doing the same job as a switch. But what's funny is they're more like a hub than a switch. They're kind of dumb. I mean, they're amazing,
Why?
but they're kind of done like a hub. Let me show you. Looking back at Packet Tracer, if I scroll down just a little bit, you can see I have a little wireless network here. Let me add the IP addresses here real quick. Now, what I want you to do real quick is down here at the bottom, click on the lightning bolt. Very Harry Potter-esque. And then click on the lightning bolt again.
Wait, what?
It's like plugging in. Here's a hub. Let me show you. What I want you to do real quick is down here at the bottom, click on the lightning bolt. Very Harry Potter-esque. And then click on the lightning bolt again. This is a connection. It's like plugging in an Ethernet cable. And we're going to plug it into the access point here and then plug it into our switch. We talked a little bit about wireless in the first video, but it's just an extension of the switch. So it connects to the switch with an Ethernet cable, and then it connects all the other devices via wireless, which we know to be airwaves or radio waves. So most of our devices, like our phones and everything else,
these are
connect
the
to
wireless
this access point, which is connected to a switch. Now, even though this access point is connected to a switch, he's actually more like a hub. And it's all about these connections right here. Let me show you real quick. I'm going to have Mr. Denny here. I'm going to click on Denny and launch his laptop. We're going to go into his desktop and go to his command prompt. And we're going to ping, let's say, the first tablet down here, 10.1.1.11. So I'll do ping 10.1.1.11. Oh, and I forgot to go into simulation mode. Let's go into simulation mode down here.
I don't
Bring
see
Denny
that.
back up. And boom. So as you can see, Denny's got his packet ready. And he sends this frame to the switch. Now, if we open...
Stop that. I need... Do you even have an IP address? Because I don't see one. Ah, here is one. So here is an IP address, and I'm using Denny to ping him. God damn it. That's... And there's it. 10.1.11. Wait, what? Oh, 10.1.1.11. It does work. I just need to be in simulation mode.
Top. We're going to go into his desktop and go to his command prompt. And we're going to ping, let's say, the first tablet down here, 10.1.1.11. So I'll do ping 10.1.1.11. Oh, and I forgot to go into simulation mode. Let's go into simulation mode down here. Bring Denny back up. And boom. So as you can see, Denny's got his packet ready. And he sends this frame to the switch. Now, if we open up that frame, what do we see? Well, we see that the source is indeed Denny over here, based on his MAC address. And then the destination, well, what is that matching? Well, if we scroll down here, we can see, yeah, it does match the first tablet here. So the switch knows that he lives on this port connected to the access point. But it's what the access point does with it that's so stupid, but it's just how wireless is right now. Let's skip forward in time. The access point has it now, but now let's see what happens. Click next. Boom.
Sends it to everyone. Jesus. Yeah.
The message was sent to everyone like a hub. Now, we'll cover wireless in more detail here later in this course, but just know for now, that's why people tell you plug into an Ethernet cable at all costs if you can, because a wireless connection is more like a hub. And the fact that all the messages are going to each device isn't the worst part. With hubs, it's just a traffic jam, collisions all the time, which is why switches are great. And we'll cover more on that later. But yeah, always prefer Ethernet cable.
Yeah, I see why now.
A wireless connection if you can. Now, later versions of Wi-Fi, like Wi-Fi 6, do help out with this. I actually made a video on Wi-Fi 6 that you can check out up there. And then as we step forward,
now I'm interested. Why Wi-Fi 6 is like that?
Back, the access point will then send it to the switch, and then the switch, like it's supposed to, will just send that to Denny. But then we have the same process happen again when Denny does send another ping. Hey, First tablet, are you there? The access point will still broadcast that out to everyone.
Yeah.
All right. Hope you have your
So
copy
it
ready.
doesn't
Time
really
for a
know.
quiz. Time to test your knowledge in what we just covered in this video. The questions
Right.
I'm about to ask you are not easy. I pulled them from Boson XM, the best CCNA practice exam you can find. They are world renowned and they are sponsoring this video, so check out the link below for that exam. Anyways, let's see what you know. Question number 1. Which of the following addresses will a switch use to populate the cam table?
The destination MAC address. C.
Select the best answer.
C. Destination MAC address. That's why I knows how it knows where it
If
is.
your answer was B, source IP address, you are wrong because the answer is in fact D, source MAC address. Remember,
Source.
switches layer 2 MAC address, switches layer 2 MAC address. Let's select our answer and get the deep down dive from Boson. So right
It
off
was
the bat, you know we're
source.
talking about a
I thought it
switch
was
in the cam table. You can mark out
destination.
A and B because those are talking about
So-
IP addresses, and the switch doesn't know anything about IP addresses. But what we're talking
It makes sense because also that's the source MAC address is the one that sends out information
about
first.
now is MAC addresses. Now it could have been source or destination. A switch will learn a MAC address and add it to its cam table when a device sends a frame to that port. And in that frame, the source MAC address will be this guy's MAC address. So that makes sense. Destination would be who he's sending that frame to, which might be a person over here. And you wouldn't want to add this guy's MAC address to this guy's port. Confusion. It wouldn't work.
Fair
If
enough.
you got that right, that's amazing. You're just a little bit closer to passing your CCNA. Next question. Which of the following addresses will a switch use to make forwarding decisions? Select the best answer.
Destination MAC address then. It's destination MAC
If your
address.
answer was destination MAC address, then you are absolutely correct. Let's select the answer and see if Boson thinks I'm right. Here is Boson's wonderful explanation. I encourage you to pause the video and read that. But looking
Oh,
at the question,
Jesus.
it's talking
We're going back. Switch will use destination media access control MAC addresses to make forwarding decisions. Switches make forwarding decision based on the destination MAC address contained in a frame's header. The switch first searches the content address memory (CAM) table for an entry that matches the frame's destination MAC address. CAM table, which is also called the switching table, is used by switch to discover the relationship between layer 2 addresses of device and physical port used to reach the device. If the frame's destination MAC address is not found in the table, the switch forwards the frame to all its ports except the port from which it's received the frame. So basically like a hub. If the destination MAC address is found in the table, the switch forwards the frame to the upper port. Source MAC address is also recorded if it did not previously exist in the CAM table. Switch will not use the source MAC addresses to make forwarded decisions. However, a switch will use the source MAC address to populate the CAM table by recording the source MAC address of an inbound layer 2 frame and the corresponding switch port that the frame arrived on. Switch will not use source and destination Internet Protocol IP addresses to make forwarding decisions. IP addresses are Open System Interconnection OSI layer 3 addresses and are typically used by devices such as routers to make forwarding decisions.
and read that. But looking at the question, it's talking about a switch making forwarding decisions. Well, we can automatically say, you know what? Source IP address is out, destination IP address is out, because again, switches don't know anything about IP addresses. Now, when a switch receives a frame from a device, this frame will have a source MAC address, let's just say 0001, and a destination 0002. The source is coming from this guy. That's his MAC address. He's trying to send it to the destination MAC address, this guy, who is probably over here. And this question explanation is perfect because it piggybacks off the previous question. The switch will not use a source MAC address to make forwarding decisions. However, it will use it to populate the CAM table. Again, if you got that right, congrats. You are even closer to getting your CCNA. And if you didn't, it's fine. Go back and watch the video. Learning is a process. It's a day-by-day thing, adding to your knowledge. You'll get there. Trust me. Didn't I tell you? Switches are amazing.
Amazing, yes.
And I know I keep saying this, have just scratched the surface. And in this video, we covered some ground on how switches work. You even got to work in Packet Tracer and watch packets and frames go across a network. You may have even issued your first Cisco CLI command, which is amazing. Write that down. Today was your first command. Show MAC address table. You looked inside the switch's brain, inside his cam table, to see the MAC address to switch port assignment. That's huge. And guys, that's about it. We just covered day one, switches. In the coming videos, we'll be talking about routers, and we'll be talking about the other layers of the OSI model, which we kind of talked about, layers 1, 2, and 3 today. We'll cover the rest soon. And you're gonna love it, trust me. If you like this stuff, you will love that stuff. And again, huge, massive shout out to Boson Software for sponsoring this CCNA series. They're making it free, so I encourage you to go check them out. They have a... This is episode 2 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the
and now we're learning about routers,
CCNA,
right?
CCNP, labs,
The fuck
and
is that
exams.
big ass thing there?
This is a router. But what is it? Routers connect us to the internet. They also connect us to other networks. In this video, we're going to see why we need them and what they do in our networks, and why I have so many of them. Holy junk sauce.
Are we gonna learn what a modem is then?
We're going to watch how a frame and then a packet will go across a network, access a web server, and then give us information back. This is how the internet works. You're going to learn that today. Let's get started.
Right.
Oh, and by the way, I'm giving away some Boson NetSim today on this video. Don't know what NetSim is? What's the best CCNA and CCNP labbing software in the business? So if you're going for your CCNA or CCNP Enterprise or anything that you're doing Cisco, it's what you want. It's what you need. I'm giving away 5 copies of any of those products. Link below to enter the contest. Hurry up.
Yeah, that's
Johnny wants some coffee, and we're gonna
5 years ago.
Check this out. In our last video, we talked about this guy right here, a switch. He's got multiple ports. You connect your computers to him, and and that's exactly what's happening here. Johnny, Mark, Denny, and Lisa are all on the same network, and this switch allows them to talk to each other. And in our last video, we explored how the switch actually helps them talk. What goes on inside this thing. And it's pretty cool. But you see now Johnny, this is Johnny in real life. He's a Raspberry Pi. Johnny doesn't want to just talk to Lisa, Mark, and Denny. Johnny wants coffee. The coffee is actually way over here on a completely different network. And Johnny's over here. Not good, right? How does Johnny get coffee? And when I say Johnny wants coffee, of course he wants to go out to networkchuck.coffee and order some coffee. But this server, where this website lives, networkchuck.coffee, is on a different network. Here, the switch can't help him. He needs help from somebody else. He needs a router. This guy right here. Oh, this guy. This is a Cisco 2911 router, one of my favorites. Oh, it's beautiful. Now, routers come in all shapes and sizes. This is just one type of Cisco router. This is a Ubiquiti router. Looks very different. And then typically your home routers look nothing like what I just showed you. A router is the perfect solution for this because a router's job is to connect networks. Let's put one on there. This is actually a virtual version of a 2911 router.
And how did you put that on? Network devices. And you did a 2911. I think this was it. Oh, it's already in there.
Look, just like the one I showed you. How neat. So we'll put the router in between. And notice on a Cisco router, there's no ports on the front. They're all in the back. So let me turn that sucker around. Now plug Johnny's switch in to the router. And then I'll plug the coffee network into the router as well.
Right.
Let's do that in virtual world. Bam, bam, and once more. Now, before we keep going, I want to ask you a question. Do we actually need this router? I mean, why can't we just do this? Let's take away our connections, move this router out of the way, and then let's just connect our switches directly to each other. That should work, right? No, it won't.
Why not?
Here's why. I mean, we could connect these two switches and make them one giant switch, and that's essentially what would happen. But the reason these guys over here and then my coffee server over here are on different networks isn't because they're connected to 2 different switches. That's not it. It's because of these guys right here. Their IP addresses. We will go more in depth on this later because there's a lot more to it. But just know that when we talk about a network, we're normally referring to IP addresses and a group of IP addresses. So notice I have 2 groups of IP addresses here. 10.1.1.0 through 10.1.1.255. With my configuration, as long as you have an IP address in that range, you're on the same network. Now this right here, 23.227.38.0 through 23.227.38.255.
It's a different network.
That's a completely separate network. But you know what? Don't take my word for it. Let's actually try this. Let's see if it'll work. Let's go back to Packet Tracer. Now, as a quick 30-second refresher on how a switch works, we'll have...
Okay, let's try that. So, can I move it? Ah, no, 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 up, stop. Okay, I don't want to connect it. I want to remove it. How do I remove a connection? Delete. Aha. Now I can make a connection, right? And there it is.
Johnny try to ping Mark over here, and then we'll have him try to ping my coffee server over here and see what happens. So I'll click on...
All right, let's try to do that. Let's pop this one out again. Oh, yeah. We can ping Mark, right? Ping 10.1.1.2. We send to the switch. Switch. Wait, what do you mean it sends us to everyone? Ah, because it didn't know who it was for. The first one will be that. Okay. And let's finish that. All right. Now, let's try to ping the server. .227.38.65. It never goes to the other switch. Yeah, it just died there. I guess request timeout, request file timeout. The switch doesn't know about this switch for some reason.
Johnny, wake him
Interesting.
up. Let me get this stuff out of the way. We'll go to his desktop, we'll go to his command prompt, and let's bring up a simulation real quick. So we'll click on the simulation button at the bottom right so we can watch this stuff happen in bullet time. And I'm going to show you something that I did not show you on the last video, and that's how Johnny will learn Mark's MAC address. Now, why is it so important for Johnny to learn Mark's MAC address? Well, if you recall from our last video, the switch, the only language he speaks is layer 2. That's all he knows. MAC addresses, this layer 2 address right here. Now, when Johnny pings Mark, he's going to be pinging his IP address. So his message, when he gets it ready, will be pinging 10.1.1.2. If Johnny were writing a letter, that's what he would put as the address. But if that's all Johnny had when he sent this message to the switch would be like, why is this envelope blank? I can't even see IP addresses. Who is this going to? That's what would happen. So Johnny must know the MAC address of Mark in order for the switch to know how to get it to anywhere. But how? This is what happens. So from Johnny, I'm going to ping Mark's IP.
He sends it to everyone.
1.2. And boom, let's watch what happens. All right, Johnny's got some envelopes. He's ready to send them out. These are frames right now. Notice we have a new message we're dealing with. It's called ARP, or Address Resolution Protocol. Essentially, it's a way that Johnny can find out what MAC address is tied to 10.1.
I didn't even pay attention to that. Let's try it again. It's... Oh! Okay, now I see it. It works a bit better now. ICPM. I didn't even do an ARP.
1.2, because he has to know that to be able to send it to Mark. Let's open that up and see what's inside. Let's click on that. And again, we're dealing with layer 2 MAC addresses, but also notice down here, we have some information about this ARP packet. Like for example, the source IP is Johnny's source IP 10.1.1.3. And then the destination IP right here, 10.1.1.2, that's the missing MAC address. He's trying to find out Mark's MAC address. And then of course, because this is a layer 2 frame, we're talking about MAC addresses, so the source MAC address that the switch will use is Johnny's MAC address. But then look at the destination. What the junk is that? FFFFFFF. This is what's called a broadcast address. It's the layer 2 switch equivalent of someone going, who belongs to 10.1.1.2? When he sends it to that here, we have some information about this ARP packet. Like for example, the source IP is Johnny's source IP 10.1.1.3. And then the destination IP right here, 10.1.1.2, that's the missing MAC address. He's trying to find out Mark's MAC address. And then of course, because this is a layer 2 frame, we're talking about MAC addresses, so the source MAC address that the switch will use is Johnny's MAC address. But then look at the destination. What the junk is that? FFFFFFF. This is what's called a broadcast address. It's the layer 2 switch equivalent of someone going, who belongs to 10.1.1.2? When he sends it to that MAC address,
yeah, but we already know
everybody.
that.
We'll click next. It goes to the switch. Let's open up that packet and take a look. Or frame, I'm sorry. See, it happens. And look at this. This is so cool. So over here, the switch receives it. And then
let me open it this again because I don't want to save it. I just want to open it. I don't want these connections. I want to connect this to this and this on this on this. More connections. What was the command again? Can't remember. Show MAC address or something like that. What was the command? I can't remember. Ah!
this to the appropriate people and not to anyone who lives at FA03.
Enable. Enable and show MAC address table. Understood me at least? Why do we have one already? Phase 6. And that's... All right, that's the router. The one I tried to delete. Not the whole router, just the connection. Okay, and now I'm gonna try to ping Mark simulation. Ping 10.1.2.1.2. And there's the ARP. And yeah, we don't see that. Okay.
A broadcast address. It's the layer 2 switch equivalent of someone going, "Who belongs to 10.1.1.2?" When he sends it to that MAC address, it's going to go out to everybody. Watch what happens. We'll click next. It goes to the switch. Let's open up that packet and take a look. Or frame, I'm sorry. See? It happens. And look at this. This is so cool. So over here, the switch receives it, and then it's about to send it out. Notice it's going to go out all these ports on layer 1, which remember, layer 1's the physical. It's these... I just unplugged something. Oh, that sound. It's all the physical stuff. So let's click next, and boom. ARP messages going everywhere. And what will happen is Lisa will go, "Oh, I'm not 10.1.1.2.
It doesn't go this way for some reason.
But Mark, Mark is 10.1.1.2. So he says, "Hey, that's me. I'm your guy. I'm over here, Johnny." So we'll step forward in time. Mark is the only one who responds, saying, "Yes, that is me." So he'll send, and then the switch sends that to Johnny. So Johnny now knows.
It already
Mark's
knows it.
address, so we can send him a ping. If I open that frame up that's sent to the switch, we see the source is Johnny's MAC address and the destination is Mark's MAC address.
Yes,
and if we continue, it'll go to Mark. Mark will respond. Bam, Johnny gets it. If we check our terminal real quick, our command prompt, it's happening. And if you click real time, it will just continue.
Yeah.
So that's what happens when someone's on the same network. Johnny knows that Mark is on the same IP network. But what happens when Johnny tries to get to the network coffee company? Let's see. Let's have him ping it. So we'll open up Johnny once more here. Go to his command prompt, and we'll ping the IP address of my coffee server. So ping 23.227.38.65. Let's go to our simulation so we can watch this in real time.
65, yeah.
Boom. Okay, so far so good. We have an ARP frame that Johnny's getting ready to find out where my coffee server lives, maybe his MAC address. Let's open it up and see. Click on that message. And, do you notice anything weird here? You know what? Pause the video right now and see if you notice anything that might be strange. Unpause. Okay, here we go. So just like before, Johnny's sending a frame to a broadcast address to say, "Hey, who's got this IP address?" But he's not asking about the IP address of my coffee server. No. Look here. This is the source IP. This is his IP address. But he's trying to discover the IP address, or the MAC address rather, of 10.1.1.1. Why? Because when he tried to find out Mark's MAC address, this right here was 10.1.1.2. That was the destination. Why is this different? Because Johnny knows. Johnny knows the coffee server is not on his network. So he's not even going to try to connect to that coffee server on layer 2. He's not going to try to discover his MAC address. He gives up immediately. Watch what happens.
Yeah.
Let's step forward in time. So Johnny sends this ARP message saying, "Anyone out there, are you 10.1.1.1? And the switch will send this out. And as we step forward in time, stepping forward, no one responds. Johnny keeps sending out ARP requests. Does anybody have 10.1.1.1? Does anybody have it? And no one responds. Who is 10.1.1.1? And why is Johnny trying to talk to him?
Wait,
Let's find out. It comes down to how we configure Johnny. Let's open up Johnny real quick. Go to his config, and the answer is right here. There it is. 10.1.1.1 is his gateway. Gateway is another word in the networking world we use for router. As I said before, Johnny knows that people in his network are 10.1.1.0 through 10.1.1.255.
Yeah, here it is.
Johnny knows that if anyone has an IP address in that range, they're in his network, they're in his neighborhood, he can just walk over and talk to him, find out where they are. Like, yeah, I know Bill. He just lives 2 doors down. I can walk over there and talk to him. But if Johnny tries to reach an IP address outside that range, he
doesn't know
knows
where.
it's not in his network, and he's going to need some help. He needs help connecting to a different network, and that's where a router comes in. So let's throw the router back in there and have some fun. This is going to be so cool. Watch this. Now, before we move on, it's important for you to know that I did pre-configure this router. Not a crazy amount of configuration, but I did add some configuration to make this work. For the most part, switches work out of the box, no problem. A router
let's open it again.
Because it has to know how to route between networks. He's a router. He has the map of how to get to things. I'll show you what I mean. Check this out. We're going to have Johnny here once again try to ping networkchuck.coffee. Let's open up his command prompt. So I'll go to his command prompt. We'll go back to our simulation. We're in simulation mode, bullet time mode, and let's watch some crazy router magic happen. So we're going to ping the coffee server and go. Now, same story as before. Johnny knows that this is not his network. He knows that Bob lives in another state. He can't just walk over there. He's like, I got to use my gateway. I got to find my router. And his router will be connected to his network. Watch what happens. Let's step forward in time. The ARP message is sent out to the broadcast. And keep in mind, the same reason that Johnny's sending an ARP packet for the router is the same reason he had to send one for Mark. He doesn't know the MAC address for 10.1.1.1. and he must know the MAC address so the switch will know how to get his stuff to the router. The switch sends it out to everyone, and Lisa, Denny, Mark, this server right here, which I'll talk about here in a moment, they're all like, yeah, that's not me.
Yeah.
But then the router's like, that's me. I'm 10.1.1.1. And he sends a reply back saying, yep, that is me. The switch tells Johnny, hey, this guy lives here. That's his address. Walk on over. So Johnny does. If we open up that frame that just arrived at the switch, we can see the source is indeed Johnny, and the destination is the router. And then we'll step forward.
Asset simulation, please.
And then we have something blinking and flashing. Let me zoom in on that. This is so cool. What's happening right here? Well, let's open up the freaking out guy right now. Isn't networking fun? Oh my gosh. Okay, here's what's happening.
Went to the router.
Receive right here. Well, if you just look at layer 1 and layer 2, we know that he received this frame on his gigabit 00 interface, as this little message says right here. But because we have layer 3 involved, we know that to be called a packet, remember? That's what routers do, man. They are all about layer 3. They are layer 3 devices. They can handle the IP addresses. That's the language they speak. So this is what the router receives.
Yes.
Notice it's from the MAC address that belongs to Johnny right here, and it's to his interface. But then look what he's sending out, and notice what's missing. Layer 2. Now, according to his layer 3 map, he knows that 223.227.38.65 is that way. But that's layer 3. He doesn't know where he lives at layer 2, and because he's about to send this frame to the switch, he doesn't know how to tell the switch how to get to him, and that's important.
I don't see that.
I don't know what his layer 2 address is. So how does the router find out? Well, how did Johnny find out?
Doesn't work.
An ARP message. He says, hey, where is 23. Blah blah blah, and he broadcasts that out. Watch. Right next to the freakout message, we have the
Okay, let's try it again. Simulation. Ping 23.227.38.65 goes into RP, goes to the switch. What? What? Okay, there it is. Went to the router. RP packet source. Alright, so thank you for being here. Thank you for lurking. Have a nice day, evening, whatever. Bye bye. Which sends out an RP request by backwards. Huh? Still don't see what the hell is going on. There was a single reply because I was so fucking slow.
ARP message right here from the router to the broadcast, and we're looking for anyone that has this IP address. Anybody got this? Anybody out there? And let's step forward in time and watch this happen. So he sends the ARP message to the switch broadcasts it out, and because the server is the only one that is on the network, he receives it. The server's like, hey, that's my name, that's me, I'm over here. So he sends the response to the switch is like, yeah, I know where this guy is. Hey router, I found him. And now that everyone knows where everyone is, Johnny's ready to send his message. So if you open up Johnny's message over here, I want you to pick up on this. In the layer 3 header, Johnny has his IP address as the source, the coffee server as the destination. But on the layer 2 level, we have his MAC address as the source, and then the destination is the MAC address of the router. So layer 3 right here is directions for the router, saying, hey router, this is where I want my message to go. And then layer 2 right here is directions for the switch, saying, hey switch, this is where I want my
You're welcome, swoosh.
The router will take care of the rest. Let's watch it happen. Step forward in time. The switch receives it. If we open that message up, we can see it's only layer 2 because the switch can only see layer 2. It's going straight to the router, so we sent it to the router. This is so cool, isn't it? I mean, it's amazing. Let's open up that router's message and look at that. This is the message he received. So layer 2, it's from Mark's MAC address to his MAC address. Layer 3, it's from
They
Mark's
already know
address
where it
to
is, so
networkchuck.coffee's
way
IP
is
address. And now for the
easier
outbound
to do
message,
it.
because he learned where the coffee server's MAC address is, he can send it out. So here's the layer 3, and then for the switch, he's got the directions right here. From his MAC address to the coffee server's MAC address, which ended in 1AC7. If we look at that, yep, it matches up right there. Let's watch it happen. Boom. The switch sends it out.
no
And the coffee
RP
server
requested
got it.
anymore.
And then the coffee server replies and sends it back. The router sends it through. The switch gets it. And then Johnny gets it. Isn't that amazing? And this happens millions of times every day across networks across the world. Isn't that just crazy? Now, I want to show you one more thing.
It happens in milliseconds.
About later. But obviously, Johnny, he wants to order some coffee from networkchuck.coffee, but you can't order coffee by just pinging the web server. You have to visit the website. And we can do that. Let's have Johnny do that right now. So I'm going to reset everything and we'll get this thing ready. This is going to be amazing. Don't let this overwhelm you. We will go over the details of how this works later on, but I just want to show you because it's so neat. I can't help myself. So we're still in simulation mode. Let's open up Johnny real quick. And instead of going to the command prompt, we can go to his web browser. So I'll click on web browser right there. And the website is...
Hello, Rebecca. Welcome to Graveyard Club. Have a seat. Grab a drink, enjoy the show. I'm doing fine. How are you? Just trying to learn some CCNA here. Some networking. Some IT networking. How about you? How are you? Okay. What did he use? Me browser?
on, but I just want to show you because it's so neat. I can't help myself. So we're still in simulation mode. Let's open up Johnny real quick. And instead of going to the command prompt, we can go to his web browser. So I'll click on web browser right there. And the website is networkchuck.coffee.
Wait, where did you... Ah, right, it is. Network Chuck .coffee. And that goes out and the RP request, yeah? Yeah. Rebecca, I'm not... no. Just sometimes I stream. Send that to everyone.
The main difference here is that we're not using an IP address, at least to start with. It's this friendly name that we normally use, like facebook.com, youtube.com. But how does that work? We know the switch loves MAC addresses, and that's what he talks. That's the language he talks, layer 2. The router loves layer 3, IP addresses. Who deals with names like this? Well, the short answer is no one. Johnny must know the IP address. Or rather, Johnny's computer must know the IP address. So when he types this networkchuck.coffee URL
they need to dock to a DNS server.
You can find out what the real IP address is, which we just pinged moments earlier. That's called DNS, and that's what our DNS server here is for. Let's watch it happen. I'll click go, and boom. Oh, whoops, I forgot to configure the DNS server. If I go to config, under his default gateway, we have DNS server, which stands for domain name service. And I'll put in the IP address of our DNS server up there, 10.1.1.50. This guy right here. So let's go back to our web browser and try it again. Go. And here we go all over again. We have another art packet because Johnny needs to get the information on networkchuck.coffee. He needs to learn the IP address, and he knows that this server, the DNS server, knows that information. That's 10.1.1.50. And that's his first job. So he has to go through the process again of learning the MAC address of the DNS server. Let's walk through that now. Stepping forward in time. Sends an ARP message. The switch will broadcast that to everyone. The DNS server responds because that's his IP address, and he's like, here's my MAC address, that's me. The switch sends that to Johnny, and Johnny's like, yes. So now Johnny can send his DNS query to find out where networkchuck.coffee is. What's the IP address? So he'll get that message ready. So he sends it out. It goes to the DNS server. We'll take a quick little peek inside that real quick. We'll open that up. And a lot of stuff going on there.
Yeah.
That's the other layers we'll talk about. Don't worry about that. But essentially,
Add device. Wasn't that much for me? What the hell? Wait, no. Wait, what? Oh. What? These are different packets then? Which router? Same thing, no? R type ARP. No, thank you. Interesting. Switch sends it back. Then Johnny talks to the DNS server again. And it's a DNS request. DNS server receives an DNS query. Name the query is resolved locally. And that's the only one that has... No. This has some other layers as well. The DNS query. And there's the decouples DPD from the... I have zero idea what those are.
Yeah, I know where that is. Here you go, Johnny. Here's the information. So he sends it to the switch. The switch sends it to Johnny. Johnny learns where this is. Now let's open it up real quick. I'll show you. Let's open that up.
Let's drink coffee right now.
PDU details. Again, don't worry about that just yet. We'll scroll down all the way to the bottom. We can see that the information, the DNS answer, is right here. The name, networkchuck.coffee, and then here's the response, the IP address of our server. So let's step forward in time. Johnny will send his HTTP.
Wait.
The DNS answer is right here. The name, networkchuck.coffee, and
DNS
here's the response, the IP address of our server.
Ah, yeah, here it is.
Johnny will send his HTTP GET request. We'll cover more on that later. To the router, to the switch. Now, what you might be noticing.
This is HTTP. Okay.
The MAC address.
That's why it's different.
The router learned the MAC address of the coffee server. No, it remembered. It puts that in its cache and it stores it. So we don't have to do it all over again. Now, it will eventually forget that information so it can relearn it. But again, more on that later. So let's step forward in time. It goes to the server. The server gets it, responds back, and you know what? I'm going to switch to real time. Let's open up our web page, and there it is. You need to drink coffee right now. And there's our website. As you can tell, it's been expertly designed. And by the way, that's real. If you want to buy my coffee, networkchuck.coffee, it's delicious. It's what I'm drinking right now. It's real.
Yeah.
I've got this lab in a link below. If you didn't follow along with me throughout this, go ahead and open it now and try it for yourself. It's really cool to walk through.
I just tried it. It's kind of cool, yeah.
The internet works. This is what happens when you get on your computer and you go to youtube.com. This process happens. This right here is your home router. You're Johnny. Now, the real internet isn't this simple, right?
It has a DNS server and just
be like this router connected to another router, connected to another router, connected to another router, and then eventually getting to my coffee website, as we covered in the first video. But the process
plus a DNS server.
The router is connecting these two separate networks. And remember, when I say network, I'm referring to the IP addresses, layer 3. These guys over here have a different group of IP addresses than these guys over here. Your home network will be a different group of IP addresses from the rest of the world. And that's why you need a router to connect to the internet. And inside of this router's brain, if you pop him open, he has a map to other networks and to the internet. Like, let's take a look. Let's have you enter another Cisco CLI command right
Okay. Let's do that, whatever that is.
now. Let's pop it open. Let's do this. I'm going to click on the router. We'll jump on over to his CLI tab. We'll hit enter and then type in enable. To see his map of IP addresses and where to reach different networks, we'll do show IP route. This is a command that network engineers use all the time. You're already doing networking right now. Let's hit enter and boom. I'm going to expand this out a little bit.
I'm seeing this here. Codes local, connected, static, RIP, mobile. Oh, geez, that's a lot. So what do we have here? The same. Subnet 2 masks. I have zero idea what that is. But we have two IPs. Directly connected gigabit. C was what? Connected and local, yeah.
Here. And this might look a little overwhelming, but here's all it's saying. The group of IP addresses that Johnny belongs to is right here. 10.1.1.0/24. That's just a shorthand way referring to 10.1.1.0 through 255. And in the router's map, he knows that it's actually directly connected to his interface, Gigabit Ethernet 1. Or I'm sorry, 00. And the same goes for my coffee network over here. There's the network, and again, it's a shorthand way of saying 23.227.38.0 through 255. And that's actually directly connected to Gigabit 01. So when Johnny said, hey, I want some coffee, I want to order it right now, and he sent his packet to the router saying, here it is, I want to go to this guy, the router's like, oh, well, let me check my map. Oh, there it is. There's the network.
So it is a map as well.
One interface. I'm going to send it out that interface. That's how the router knew. Now, this is very simplistic routing. Routing gets crazy. Like if you were to look at a router on the internet, let me show you real quick. This is actually one of the routers on the internet. Check this out. I'll enter the command show BGP, which is a routing protocol. We'll learn more about those later. IPv4, unicast, and let's see what we got. And all of these are routes to different networks on the internet.
Jesus Christ.
I can keep going. I mean, look at this. This is insane. This is this router's map. This router is probably huge, very expensive router. But this is an example of A, how big the internet is, and B, what a router can do, why it's so powerful. All right, we'll never reach the end of this. I'm just going to stop. And that was episode 2. Now I changed it from days to episodes. Makes more sense for me. If you have any comments or questions, let me know below. I would love to hear your feedback on this. And if you need help, don't be shy. Ask some questions below. Either myself or some others will join in and help you out. Or hey, join my Discord. We've got so many professionals in there who are willing to help out with really any questions you have. And if you want to help me do more of this, create free training along with David Bombal, check out the This Is IT membership, link below. By joining, you help us create more free content. There's also some amazing content. This is episode 3 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. Okay, I need you to stop and think about this for a second. I want you to appreciate the fact that this device right here, a Raspberry Pi, can connect to the network and talk to my iPhone. They can share photos, they can email each other, do whatever. It might not seem amazing because this kind of stuff is just
it's amazing.
We're used to every day. But once upon a time, a long time ago in a galaxy far, far away, if you had a device that was made by 2 different companies, they could not talk. This is where things like the TCP/IP model or the OSI model, networking models, save the day, like for real. But how?
Well, when I was already in elementary, there was already the IP addresses, so it was before my
Let's take a look back
time.
in history real quick. A long time ago. I'm talking Stone Ages, 1960s. Some smart guys were sitting around with their computers and they were thinking, man, gee willikers, I really wish they could talk to each other. I wish I could share a file with you, friend. But they couldn't. But then they hatched an idea. They came up with something. They go, what if we can network these things together? What if we can connect our computers together and we could send data across? They did that. 1969, the birth of the first network. They called this ARPANET. The US DoD, or the Department of Defense, came up with it. And it was revolutionary. Like, people could actually have their computers talk to each other, which I know sounds like not a big deal right now, but back then, that was it. That was
Even nowadays is a big deal.
Hold on. Here's the problem, though. This was more of an idea. Like, they legit did it. Like, here's the first, like, network diagram I think there ever was. Check this out. Look at that thing. I have no idea what's happening. And when I say idea, they were like, yeah, this is a cool thing we can do. They actually invented what's called packet switching, which is what we do today. But what they didn't have yet is the how. How do we make these computers talk to each other? You see, that part wasn't quite ironed out. But the idea spread like wildfire. So companies like IBM, they were like, heck yeah, we have computers. Let's design our own network. And they did. It was proprietary, meaning it only worked with their stuff, which is fine if you have an IBM computer, but there wasn't just IBM. There were other companies, and guess what these other companies did? They also designed their own networks.
as well.
Let me step back. When I say design, I mean they like invented their own networks. They came up with the idea of how to actually connect computers together. And because these networks were proprietary, they couldn't really play well with others, meaning these networks could not communicate. You couldn't have this device talk with this device. They were basically speaking different languages. This network over here is like, bonjour. And this network over here was like, what? No idea. I want to hammer this home because this is some primitive stuff. I'm talking like this is before Ethernet cables were invented. Like we're so used to Ethernet cables. We're so used to the Ethernet ports. These weren't a thing. Each of these companies had different versions of whatever they called theirs. Like, you ever try to charge your iPhone with an Android charging cable? It doesn't work. It's just not compatible. That was the networks of yesteryear.
Nowadays, it's compatible with the newest one because USB-C.
Or a long time ago. Now, eventually they realized, hey, this is kind of stupid. Maybe we should all use the same networking stuff. Yeah, let's do that. Now, easier said than done.
Accentuate the positive, eliminate the negative.
Thank you, Bagel. I'm trying to learn here. Goodbye. Welcome back, Sadat.
And committees, and I want to do this, I want to do that. You're wrong, sir. A lot of that kind of stuff. Now, there's a long and maybe interesting history, if you're into that, of how this all came about. But we eventually ended up with a networking model.
Good. Eating is good.
That defines
I ran out
how
of
we
drinks.
Connect our stuff. So that when IBM makes a computer, when Apple makes a computer, when Microsoft makes a computer, we're all putting the same technology inside that computer to make it talk to the other computers. That's why it's such a beautiful thing that a Microsoft computer can send a photo to an Apple computer. We're all using the same networking technology. We're using the same networking standards. Now, actually, honestly, we ended up with two models. One
feel
that
like
we
a Swede
actually
again.
used, and then one
What did you feel like before that?
still cling on to and talk about all the time. I'll show you. The model we use today is called TCP/IP. This is what every computer supports and has implemented into their system. The TCP/IP model, and they also call it the TCP/IP stack. Now, the other model, he wanted to be the one that won so badly. People were on his side. They were campaigning, but he just did not win. TCP/IP won for a variety of reasons, but it's just more widely adopted. So then why am I still talking about him if TCP/IP won? I'll show you. It's weird. Now again, TCP/IP is just a list of rules or guidelines, standards on how computers can communicate, how we design those systems. And there's a lot
you're too full. That
things
makes
more
sense.
Simple, more digestible, easier to understand and implement. We divided all those functions into layers. Layers like this right here. Each of these layers defines some kind of protocol or standard.
I might stop you after this one, but physical network transport application. Usually I work on the application layer. I don't think about transport or network. Now I'm learning about those.
We'll use when computers connect. So for example, the physical layer, we know it's going to involve Ethernet cables. The network layer, all about IP addresses and routers. So with this standard, we all agreed we're going to use IP
Alright,
addresses
so
when we
do
communicate
that
over
and
the internet.
relax.
Before that standard, that wasn't really the rule. You could have done anything. You could have used names from Star Wars or something. I don't know. Transport, we got TCP, UDP, port numbers. We'll talk more about that later. And then application, like, hey, when I open up my web browser and I go to netflix.com, what protocol am I going to use? Do we all agree to use the same protocol? We all agree to use the same stuff, and it's beautiful. Now we can all talk together. We can all network together. Now, this is the traditional view of the TCP/IP model, the layers we see here. If you're studying for the CCNA, the 200-301, you might see the physical layer divided into two separate layers like this, which I have.
Data and link.
And if you watch my last two videos in the series, You're already familiar
Data
with
link
the first
physical.
3 layers here. You've already
Yeah.
seen them in action, going through a network. We got our physical,
Physical,
the Ethernet cables,
data
the network
link.
cards, the electricity flying. That's our layer 1. And then we talked about our data link layer. This is where our MAC addresses come in. Our layer 2 addresses. How hosts on the same network can communicate. And the switch uses those layer 2 addresses, those MAC addresses, to know
Thankfully,
where to send
alright.
information.
And
And of course, we have our
sleep.
layer 3, our network layer. We know this to be IP addresses. We know that we assign our devices IP addresses, and this is how they communicate. This is how the router can know where to find people and route those packets to the right people. And then we have our other layers, and we will talk about those, but not right now.
Right.
We'll get to it. Okay, now, what about the OSI model? Where does this guy come in? Well, let me show you. Similar to TCP/IP, he works on layers. In fact, he shares the same layers as the TCP/IP
Yes.
model. He just has a few extra. So physical data link and network transport, yeah, let's talk. That's the same. But then at the application layer, it's a bit different. We're going to add
Really
a
now?
couple more. We're going to add a session layer and a presentation layer. Let me scoot this guy up a bit.
What's the difference?
Now, as you're studying networking, as a network engineer, the main difference between the TCP/IP model and the OSI model are these 2 extra layers. Now, the concept of these layers, what they bring to the table, do not go away with the TCP/IP model. I'm saying it too much. All that happened is we stuffed those 2 layers inside the application layer. But Chuck, you
Yeah.
still haven't told us why we're talking about the OSI model. Why are we even talking about it? This is why. I told you these 2 models were at war with each other. Who was going to win? And during those wars, it was widely believed that the OSI model was going to be the one that was adopted, which, by the way, stands for Open Systems Interconnect. And because it was thought to be the clear winner, we started using the layers that the OSI model has as our day-to-day terminology. And even when TCP/IP was the clear winner and it killed and murdered OSI, we still refer to the OSI layers when we describe network functions. Now, again, not a huge deal because layer 1, 2, 3, and 4 are the stinking same as the TCP/IP model, as long as you're referring to the Cisco version of it right now.
But the
when you get
5,
up to
6,
the layer
and
5,
7.
layer 6, and layer 7, clearly we got a little disconnect there. But when
Yes.
network engineers talk about it, OSI always wins. We will always, always, always refer to the application layer as layer 7. This right here is layer 7, and there's only 5 layers here. That's just how we do it. It's how we roll. But I will say this. If you're trying to learn networking, if you're studying for the CCNA, you need to know both of these models. And there's a fun way to memorize this.
Jesus,
So the
that's just
OSI model, seven
overly
layers, it's hard to
complicated for
memorize.
no reason at
I'll
all.
use a mnemonic device. So application, presentation, session, transport, network, data link, physical. Let's try all people seem to need data processing. I'm sure there are better ones. That's just how I learned it. Let me know below if you have a better one. But I can't tell you how many times
Jesus.
throughout my career I've referred to that phrase, that mnemonic device, to remember the 7 layers. And then what about reverse? What if you're not going from application to physical? What if you're going from physical to application? Which can happen routinely, right? I got one for that too. Please do not throw sausage pizza away. Makes me hungry every time. Now again, a big reason to remember and memorize
Jesus.
the OSI
All people seem to need data processing, and please do not throw sausage pizza away. Jesus, okay.
model is A, you need to know it for any exam you might be studying for, and B, it's honestly the thing we reference the most when network engineers are troubleshooting or working through any kind of networking issue. Oh, that's a layer 7 issue, application. Hands off, not my problem. Or hey, that's a layer 1, layer 2, layer 3, or layer 4 issue. Okay, time to see
Okay, about layer 4 now. That's the transport one.
what you learned. Get your coffee ready, your thinking cap on. Let's do this. Exam questions right now. Question number 1. Which of the following operates primarily at layer 2 of the OSI model?
It's the switch and hub.
Select the best answer. And go. If you said the answer was switch, you're absolutely right. If I hit show answer, fingers crossed, yes, I'm right. The switch operates at the data link layer, layer 2 of the OSI model.
Hub as
Router?
well.
Nuh-uh.
Oh.
Where's the router operate at? Layer
Hub
3,
operates on
IP
layer 1.
addresses,
Oh, never mind.
network layer. The hub? That might have been a little bit confusing for you because we compared switches and hubs in one of our earlier videos in
Yeah.
the series. Where do they operate? Remember, hubs are stupid. They got no smarts. They don't operate at layer 2. They're not even aware of MAC addresses. All they do is just repeat electrical signals when they receive them.
Okay, so
Out
they
all
just
ports.
repeat
So they are
those.
primarily physical. And quiz, what layer is physical? Layer 1,
Layer
right?
1.
And then a WAP A wireless access point
It's a
this was
layer
kind of a
1.
tricky one because they do operate at layer 2. They also operate at layer 1. So they're not primarily focused on layer 2. So if you put that answer, you're half right. You're kind of right. But we're looking for what primarily operates at layer 2. And that, of course, is a switch. Question number 2. Which of the following devices operate primarily at the physical layer of the OSI model? Select 2 choices. Now we kind of
Operate parameter physical layer. So layer 1. Hub. I guess bridges and
already
repeaters.
covered this. Let's see what you got. Go. Okay, here we go. Here are the answers. A, repeaters, and C, hubs. Let's
And
see if
what
I got it
are
right.
bridges?
Boom. Now this may have been a bit tricky for you because we haven't talked about bridges, and that's fine. But through the process of elimination, we know that, hey, switches, those are layer 2, and we just talked about that. Routers, layer 3, of course. We
Yes.
just said that hubs are physical. And I even mentioned that hubs will repeat electrical signals when they receive the electrical signals over the wire. And repeaters do the same thing. Bridges, on the other hand, are similar to switches in that they do deal with layer 2.
Okay.
But guys, that's about it. If you like this video, hit that like button. If you have any comments or questions or need help with your CCNA, comment below. Or you can jump into my Discord.
Let's go to the next one and the
This
last
is
one.
episode 4 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs,
Check if there's any lab buttons.
TCP/IP, and OSI. Networking models that define how we connect our computers. Without these, we wouldn't have networking. So in this video, we're going to watch it happen. We're going to follow a packet as it goes through a network and how it interacts with each layer. Let's do it.
Let's see. Timestamps. Yes.
Okay, same scenario as the last video. Johnny wants some delicious Network Chuck coffee. So he needs to go over the internet to access networkchuck.coffee to order some coffee. Let's watch his packets go across the network and we'll analyze the layers as it goes across the network. Let's check it out. Now, I'll say it again. In reality, we're using the TCP/IP model, which is this, but for reference, I'm going to use the OSI model. So I'll add in those extra layers, the session layer and the presentation layer. Just gonna add those in there, stack them up. And if you want to follow along, which I highly encourage you to do that, it's really helpful to watch this actually happen, use your own computer. So I got a link below, download this packet tracer file that I'm about to walk through. Go ahead and do it.
Okay, where it is. Course. Sponsor. Or here it is. Gimme. Wait, it's the same one as the previous one. Save. Yeah. I don't know why it looks like this. Polorski. What classic? Please restart. Oh. Lab.
Right now. I'll wait for you. If you pause. Otherwise, here we go. So using simulation mode, we'll watch Johnny go all the way across the network to access networkchuck.coffee, which is this server right here, and order some delicious coffee. So let's click on simulation and watch this in bullet time because it's amazing. Now, as we go through this, I want you to notice one thing. I have our traffic filtered, meaning that I'm only looking at HTTP and HTTPS traffic, web traffic, things you might use to access a website. I'm telling you this because you won't see things that we saw in the last video, like ARP requests to discover a device's MAC address. You won't see a DNS query, so Johnny can discover the IP address in networkcheck.coffee. If you want to see those things, you can. Just go edit the filters right here.
Yeah,
You can
I
unlock
just
all
did.
those goodies. So we're going to open up Johnny's laptop here. We're going to navigate over to his desktop and click on web browser. We're going to type in https://networkchuck.coffee and go. Now, nothing happened because we're filtering traffic.
Wait. I don't want to send any emojis. Network. Chuck.coffee. Even this. Followers claim. No slate. Want to see shit. I bet this is even dark. You know what? Maybe if I go for dark mode, that will help. Hey, Deskera! Welcome. Yeah, I just learning CCNA. I don't have a course or something like that. I just want to create a home lab as well. And I managed to fuck up a router with some things that I just don't understand. But hello, yeah. I'm trying to learn it. This is the probably last episode I'm doing today. But yeah.
This is big brain time.
Hey, Tecto, yeah, it's indeed big brain time. And jeez, why was that my nose that got big? Racer Lab. Hopefully this will look better now. Desktop. Web browser. Anyway, how are you guys? Welcome to the Trivia Club. Have a seat. Grab a drink. Enjoy the show. Show of me just fumbling around like a freaking idiot. As usual. Wait, I forgot to go to simulation. I only care about application layer right now. Yes, it is indeed Tommy Wiesau. And we have Mark as well. And Danny. And Lisa. We have the whole crew here. Network Chuck. And by the way, Deskera, how further are you in with your study? Network Chuck the coffee. These are at least readable. Finally. Also, I have an issue that these are too big.
Let me step forward in time and watch things happen. There we go. So we see here we have our blue message, our blue packet that Johnny's getting ready to send out. In our simulation,
Purple for me, but yes.
We have two separate messages. Why? Well, one is what he's getting ready. The other is what he's sending out to the switch. Let's open up that first one and take a look. I'll just select that first message right here. You can see we have our wonderful 7 layers of the OS.
7 layers,
Again, I'm
HTTPS.
telling you, the networking
Layer
world always
4
uses the
is, I guess, the
source port
transport
always.
layer.
So let's analyze this. First, Johnny starts
Is
off by
source
using layer
port.
7. What's layer 7?
Destination port.
Layer. What application is he using? Well, we got a message right here. Because we have that layer selected, the HTTP client sends an HTTP request to the server. What that basically means is that Johnny's web browser is attempting to access a website. So simply, this is the application layer. The protocol we're using here is the HTTP protocol. And actually, we're using the HTTPS because it's secure and encrypted. But this is an example of an application layer protocol that is used by things like, hey, your web browser. You're using that right now. So Johnny types in
FTP is our application layer as well.
He hits enter and his computer gets to work. And so again, the application protocol we're using
Send segment information, segments number 1, tag number 1, data length.
And gets it ready to send out. Now at this point, the computer's goal is to get the data all the way down through the layers, down to the physical layer, so it can go across our Ethernet cable through the internet to the other server, to the networkchuck.coffee server. But what's happening in all this mess? What's going on? Let's talk about it. Now we're going to skip these 2 layers for now. We will go into more detail later. But again, typically they're meshed into the application layer anyhow, so it's okay. Looking back at Packet Tracer, we're on to layer 4 now. Layer 4 is our transport layer. For now, the way I want you to think about it is how can we transport the data? How can we get it there? And we really have 2 main options.
Layer 1 it sends to the
or
switch.
UDP. Now, I'm not going to cover this super in-depth
No,
right
see,
now.
Johnny.
Just know that when we use TCP, it's more reliable. It's when we want to make sure our message actually gets there. We have mechanisms in place to make sure that if it doesn't get there, we
Just bring a small monster catching dungeon crawler. Oh, what is that game?
It's typically seen as a faster transport method. So when it comes to the transport layer, these are the 2 main options we have. And then we have our ports. Now,
This is what I understand is between TCP and UDP, as I understand it, is like TCP is a sniper rifle. You hit precisely where you want it, and UDP is a minigun. You might hit it, you might not, but you're sending it fast. Serial Ultimate, I don't know that one. I will check it out later then. Okay, do not stop.
the destination port here is destination 443. You
Yeah,
like
destination port.
443 is reserved for HTTPS traffic. You might also be familiar with port 80, which is HTTP traffic. Again, we'll cover more in detail.
Fairly simple in money, but a lot of new systems have to form it as you go through levels. So it's incremental, basically.
And the transport information we're going to use will slap on as a layer 4 header. We'll attach that to our data. And inside this header are things like, hey, we're going to be using TCP, and we'll be using port 443. Now, what just happened here is important. The process of taking our application data and then scooting it on down here and slapping on that layer 4 header, that's called encapsulation. This encapsulation process actually happened up here as well. The web browser encapsulated whatever Johnny wanted to send to the networkchuck.coffee server, which is him saying, get me some coffee. It's a message saying, get me some coffee. He encapsulated that into a HTTP header, which is our data. The way I like to see this is, let's say, for example, the data is like a message, a letter. We encapsulate that message into a HTTP header, which is our data. When we move down to the transport layer, we took that data envelope and we put it inside another envelope. We encapsulated it. And this new envelope has our data inside, and this is our layer 4 header. And that's the way I like to visualize encapsulation. We'll keep taking our letters and just putting them inside other envelopes, other letters, until we get to the bottom, which is our data link. And I'll show you. Oh, and by the way, this message right here, when we have our data encapsulated...
In a way, yeah, alongside base customization, fusing monsters for more traits
and now we're getting into familiar territory. We're at layer 3. Layer 3, again, is our network layer. And if you watched our previous video, you know that layer 3, we're dealing with IP addresses. We're dealing with routers. Love that stuff. So in this layer 3 header, we see that we have our source IP address and we have our destination IP address. This IP address being Johnny's IP address, and this IP address being the IP address of the networkchuck.coffee server. So we'll drag our segment down onto layer 3, and we'll encapsulate that segment by adding a layer 3 header. And again, our layer 3 header is going to contain the IP address information, and we're basically telling our router where to send this. We're giving our router directions. We're saying, hey, Mr. Router, here's my source IP. This is who the message is from, which is 10.1.1.3, and then the destination IP address, which was 23.227.38.65. Now let's test your memory. You would have learned this from the last video. What is this new message we have? What is it called? What do we call that? If you said packet, you're absolutely right. A packet has all the layers above it. The transport, session,
packet, and after that
all
frame.
layers encapsulated with a layer 3
Yeah,
header
that's
telling the router, hey, here's where you send this.
that's what I'm learning. Yes, the CCNA, because I already did once networking stuff. I explained one of the in the one of the Steam Next Fest streams that I did plan out a network, and I did try to attempt to create one at my friend's place because his router went kaput. It's broken. So I bought him a new one with the caveat that I can customize it. And he agreed. I tried to customize it. I deleted the router firmware and put on OpenVRT. Which is an open source router firmware. Works great. In my opinion, when I set it up, everything worked. No issue. The next day, it kept itself. No internet. After restart, worked. Then I looked at the logs. The logs were full with one of the computers just can't decide if it's got a static IP or dynamic IP. When it's directly set, he has a dynamic IP. The router wants to give him a dynamic IP, but no, he wants a static one. No, he wants a dynamic one. What the fuck is wrong with you? Then, because it was LTE router, the LTE port, the one that communicated with the cellular network, just kept out every day again. No apparent reason. And of course, then there was a firewall which didn't let through anything. If you want to go outside, sure, it worked. No problem. Happy day. But as soon as anything tried to get in, even though I allowed to get it in, allowed the firewall to, hey, somebody wants to communicate on TCP protocol on the port 93. Allow it through to anybody. Nope. Cannot allow that. I don't know why. I set up port forwarding as well. Even that didn't work. And the other issue I had, we have two similar printers that needs to be reached from outside. And both need port forwarding. But I have zero idea how to port forward the same port to the same machine. How do you do that? So as soon as I get my next paycheck, I'm gonna buy a new router for him. And after that, I'm gonna take the old router and tinker with it myself here at home, because I want to get a new router myself as well. I love my router that I have here. It's fine, it's working, nice. I have 3 routers in my home, and the first 2 only need because I need to somehow connect to the internet. Only those 2 can connect to the internet. And my third router, my original one, is the one that can do all that. And I want to simplify it if it's possible. Or maybe not, I will see. Maybe I should upgrade to the newest model, get a Wi-Fi 7 protocol or something like that. But anyway, let's go back.
And now we're at layer
but yeah,
2.
that's what I am, where I am.
Layer 2 is our data link layer. With data link, our layer 2, we're dealing with MAC addresses. We're giving our switch directions to the next stop that our information is taking. In this case, it'll be our router. Here we have the MAC address of Johnny's laptop, and here we have the MAC address of the router. So now I'll move down our packet into layer 2, and we'll slap on our layer 2 header. And layer 2 will also have a trailer as well. And this will encapsulate it into a message that we call, well, what do we call it?
Frame.
We call messages that deal with layer 2, that deal with MAC addresses and switches. If you said frames, you got it. This message is indeed a frame. A frame has all of these layers encapsulated down, and inside these layer 2 headers, we had the directions for the switch, telling the switch where to send his message. So in this case, we have the source MAC address, which is Johnny's MAC address. And then we have the next stop, the destination, which is our router. And that's pretty much it. We've encapsulated all the layers down to a frame, and now we can send that frame over the physical layer, the Ethernet cable. So he hits the wire, and boom. And actually, he's up here. So he goes from Johnny to the switch. Let's watch it happen in Packet Tracer. If we step forward in time, we see that frame go to the switch. If we open up that frame, we're only seeing layer 1 and layer 2 because the switch can't see anything else. All these layers right here have been encapsulated down into this frame. And when the switch receives this frame, he's got this bulky envelope, but he only opens the first envelope. And he opens it up and goes, oh, well, it's going to this MAC address, which if I look in my CAM table, my MAC address table, I can see that MAC address belongs to this port. I'm going to send it out this port. That's where the router is. See right here, he looked it up, and Fast Ethernet 06 is the port that the router belongs to. Let's
It goes on to...
Boom. It goes out to the router. And boom, it also does it here. If we open up that message, the router did indeed receive a frame. And he made sure that it was for him. It came to his MAC address. He will then do the opposite of encapsulation. He'll de-encapsulate it, which basically means he opens the next envelope to see what the next layer says. So he takes a peek at layer 3. And we're dealing with the packet, with the layer 3 header, the layer 4 header, and the data. The router looks at the layer 3 header, sees where it needs to go, what is the destination,
and sends it.
Looks in his routing table. He's like, yeah, I know where that goes. I've got my map. I'm a layer 3 guy. And he then proceeds to send it out to the switch. Now, something important happens here. Remember, the switch can only deal with layer 2. If you recall,
so he gives another layer 2 header and trailer. So basically creates another frame.
Because he can't see IP addresses. So after the router learns the MAC address of networkchuck.coffee using ARP, he encapsulates his layer 3 header, which is the IP address information, inside a new layer 2 header. And he changed the source and destination MAC address. And he had to change it because before, the message he received, the source MAC address was Johnny and the destination was himself. Now he has to change it to being the source is himself and the destination is networkchuck.coffee. So he encapsulates that. It's now a layer 2 frame and he sends it out to the switch. We'll step forward in time in Packet Tracer here. The message arrives at the switch. If we open that up, here we are again, switch eyes. We can only see layer 2 and layer 1. The switch looks in his CAM table, his MAC address table, sees that, hey, networkchuck.coffee does indeed live on Fast Ethernet 01. That's where I'm going to send that sucker. That's where I'm firing these electrical signals. And he does that. Let's watch. We step forward in time once more. Boom. The frame goes to networkchuck.coffee. If we open that message up, we now have all the layers once more. And here's what just happened. The switch sent this frame to networkchuck.coffee. Now, because the server that runs networkchuck.coffee was... Because
it's arrived at the destination, it goes back to application here.
Frame, it knows exactly what to do. It'll first do exactly what the router did. Look at the layer 2 header. Make sure that, hey, this is actually for me. It's my MAC address. Hey, cool. He'll take a look at the layer 2 header. He'll open up that message and go, oh, yeah, this is my MAC address. It's to me. Awesome. He'll then de-encapsulate or open up the next message and look at the layer 3 header and go, huh, look, it's for me too. This is my IP address. Awesome. He'll then de-encapsulate it once more, opening up the layer 4 message and going, oh, hey, we're using TCP. Oh, and awesome. I love 443. We're using port 443. And then he sends it up to the next layer. And then finally, the last layer, the application layer, opens up that last message and goes, oh, it's for me. HTTPS, it's browser information, it's website stuff. Awesome. So
now I'm interested how would the presentation would look like even. Because we don't use it anymore. We don't use the OSI model, but the TCP IP model.
Network across Ethernet cables and such, touching each device, a switch, a router, another switch, and then finally arriving at networkchuck.coffee. NetworkChuck.coffee took that frame and then de-encapsulated the entire thing to look inside and see what was meant for the web browser, the application information. And of course, in this case, the data was a request for his web server. Johnny's wanting to buy some coffee. And Johnny's like, hey, I'm trying to get to the homepage of NetworkChuck.coffee. Can you give me the homepage so I can shop? So the web server reads that request, which is inside the data, and the whole process starts over again. The NetworkChuck.coffee server encapsulates all that information into a frame, sends that to the switch sends it to the router to the switch to Johnny, and this is what Johnny receives. All right, quiz time. I hope you have your coffee ready because these questions I chose are kind of difficult. One is from the old CCNA, and one is from the old CCNP route exam. So let's see what you got. Let's go.
All right,
Question
let's see.
number 1. Which of the following functions are performed by the application layer of the OSI model? So
OSI model. Again, we are learning from that, learned the TCP/IP and the application. Managing communication. Managing communication application. Hey, Halfdan, welcome on Kick. Hello, Halfdan, welcome. I still don't have set up any notification for Kick, but I will be working on it. But hello, I see you on Twitter a lot. Hello and welcome to the Graveyard Club. Have a seat. Try, grab a drink, enjoy the show. How are you? I guess convert into... No, that's... not presentation. Directing data to the correct program, I guess.
3 choices. Now, if you just started studying
But I've been here for a while now. I just never used it.
When I encounter a difficult test question, I start with the process.
Thank you for finding me. Thank you for finding me.
To do with the application layer, which again is layer 7.
Maybe I should follow you back.
I think D is probably.
How? Is this a follow? I think this is a follow, right? I clicked on something and I did follow you. Okay. But yeah, I'm on several. Now, I think it still doesn't work. Social. It only works on Twitch as of yet. But let me check. You action history socials. Do I have a source? Common source Twitch. So if I go to actions and add on if core. Not action, logic, if, input. Command source equals Twitch. Then send out the message. I have a combined alert widget that works for Twitch. Oh, really? What are you using? I'm thinking of converting here over into streamer bot. But again, it's work and stuff like that. So it needs time. And now I socials because that should give me another. Oh, it uses streamer bot. Do send it over to me, please. Common source kick. Go back to actions. There's no if else with that. If else, huh? No. Ah, I know Nutty. Yeah. I'm using his chat, so... But I don't like how he's... Well, I can change it. Maybe I should change it. Okay. I know Nutty, and I do love his videos as well. As you can see, I'm using his stuff here. Should be able to see it. Nutty.gg. Multi-stream updater and the stream up as well. But I'm mostly using that and the chat as well. I'm using his chat. Or I should be using his chat, I hope. Am I using his chat? I don't know. Sure, go ahead, post it. Yeah, I'm using his chat. Widget.naughty, horizontal chat. I'm surprised it doesn't need anything else in streamer bot. Anyway, add, core, logic. Oh, switch. Switch. Then this is better. Command source. Add case. Yes. Cases. Which add kick. Add. Okay. Wait. That's. Okay. Case. Which. Kick. It's add. Doesn't need to be kick sensitive. I can put it here. Then I don't need this. No. Just delete one. Delete sub action. Yes. Well, I got a few kick followers, mostly bots and CG artists, say basically bots. Odd and kick chat. Send message. Something. Honestly, I need to do this. Now let's try it out, if it even works. Socials. And it didn't do anything. And that doesn't work. It does work in a sense. Am I? Command? Så Orse. You enter the wallet for the left hand side the Okay. Then why are you not? But the wallet will be tested. Perform parsing with arguments. Okay. That's what missing here. Maybe now it will work. It does work on Twitch. Let's check out here. It does work there as well now. Yeah, so the last one is YouTube. Command source YouTube. Yeah. Let's add another case, which we call YouTube. And add YouTube, send message to channel, all. Do we need a default case? We kind of need to. In default case, it does nothing. So if I write in socials now, socials, it sends it back. Nice. Very, very nice. I need to set up it like that for the rest of it. But yeah. Anyway, which of the following function perform the application layer to OSI model? Managing communication between applications, directing data to the correct program, and converting the sometimes converting data to correct data format as well.
All. Managing logical and physical addressing. When I hear that, I think MAC address is layer 2, definitely not layer 7. Another one that you might pick up on is that B is probably not the answer either. Ensuring error-free data delivery between devices. This makes me think transport layer, and specifically TCP. TCP gives us reliable
that is layer
delivery of
4
our packets of our data. So now we're down to 4 choices, and I'm going to go ahead and select the right answers. And I'll explain why. A, C, and E. Let's see if I'm right.
Yeah, I
Boom.
basically guessed correctly.
This is correct for the OSI model, so these 3 options are absolutely applicable to layer 7. The one we didn't select down here, the one we didn't eliminate. This is part of the presentation layer, which is layer 6. But as part of the TCP IP model, layer 6, layer 7, and even layer 5 are all clumped together in the application layer. And if we had talked about the presentation layer in detail, you would have known that this is not it. But we didn't, so it's okay if you didn't get this. Now C and E, we probably could have just guessed that without having even known anything about layer 7. Managing communications between applications, directing data to the correct program. Program is another word for applications. A would have been a bit more fuzzy, but just from the process of elimination, we would have got that one. Question number 2. Which of the following relies on a 3-way handshake in order to provide connection-oriented, reliable data transfer between networked computers?
TCP.
So that's the best
TCP.
answer. Now again, this is a question that has terms you have not learned yet, or possibly.
It's TCP. I know this because I use it a lot.
Handshake. We haven't talked about that yet. But through the process of elimination, we can look at these answers and go, that's probably not that. So for example, ARP. When we talked about routers and switches, we learned what ARP does. It's how a host on a network can find out what MAC address belongs to a certain IP address.
It's asking for an address, so it's not that.
DNS, we saw what that was in our router video.
It looks up IP address for names.
Networkchuck.coffee to an IP address. So that's not it. And then down here, even though it looks kind of weird, RARP. It stands for
RAR. RAR XD.
It's ARP and reverse. You got the MAC address, but you want to find the IP address. So that's
so reverse ARP.
We have 2 options, and we just learned about these, didn't we? TCP and UDP are 2 of the main protocols we can select when we are using the transport layer. Now, out of those 2 options, which of them do you think provide connection-oriented, reliable data transfer?
TCP.
Well, UDP, no, it's fast, but it's not reliable. TCP.
Because UDP just sends out our data, not caring if it arrives in there or not.
We are right. Now, if you got that right, that's impressive. That's a CCNP level question
needs it.
from the old CCNP route. In the route exam, I failed that 3 times. 3? No, 2 times. It was a tough exam. Well, guys, that's about it. If you like this video, hit that like button. If you have any questions or comments or need help with the CCNA, comment below or jump into my Discord server. I got a link below for that as well. If you want to see more stuff like this, more courses, check out.
And I'm stopping here. And I don't know what happened with Halfdan, if he posted it or not. Maybe he did. I don't know. Wait, there's AI chat. Oh, it got AI chat filtration. Oh, god damn it. Okay, you know what? Let's go with this one. Maybe later on I can do the banned words as well. Oh well. Anyway, I think I'm gonna stop here. I really don't know if it's raiding or not. Gig doesn't have raiding yet. I know YouTube has redirecting, but I'm not using that. So, I'm gonna go and rate somebody else then. Wait, what kind of categories are there in? Is there an IT category on Twitch? Or learning category? Co-working and studying. There is one. No, let's search network. Ah, network check is there. But nobody interested. So you know what? I'm just gonna raid one of my friends then. And whom I be raiding? You know what? We're going to Dan because I feel like it. I haven't raided him in a while. The Dragon King. So thank you for being here. Thank you for watching. Hope you learned a little bit as well like I did. If not, well, I hope you at least enjoyed the chill time with me. And have a nice day, evening, whatever have you. And bye-bye.